A system of equations is when you have more than one equation and you're trying to find solutions that work for all of the equations in the system. One way to solve a system is by graphing. So I'm going to graph the two lines. The first line has a y-intercept of 2 and a slope of -1. So I can go down 1 over 1 all the way across the graph. The second graph has a y-intercept of -4 and a slope of 2. Those two lines cross at the point 2, 0, so the solution to this system is 2, 0. And that's because if we plug in 2, 0 into each equation, we get something that is true. So the point 2, 0 is a solution to the first equation, and it is a solution to the second equation. This sort of system that has one solution, 2, 0, is called consistent and independent. We're used to just saying it has one solution. When an equation has one solution, the two lines are going to cross somewhere. And wherever they cross is that one solution. Consistent and dependent would be two lines that are the exact same line twice. We talked about having coinciding lines before, two lines that have the same slope and the same y-intercept. That's what consistent and dependent would be. And inconsistent is going to mean there is no solution. So in terms of the graphs are never going to touch, which means the lines are parallel, or they have the same slope, but a different y-intercept. Graphing isn't always the most convenient way to solve systems. Sometimes it's just difficult to graph it. Other times when you graph it, they may be cross and it's not exactly on some nice points, so you have to estimate what the solution is. So when graphs don't work or they're inconvenient to make, there are other methods for solving systems. You can solve them by substitution or by elimination. If you're going to solve it by substitution, you need to start with getting one variable by itself in one of the equations. In this case, I can get x by itself if I minus 5y from both sides, and get x equals -5y minus 3. I'm going to take that value and substitute it in where it says x in the second equation. Now I have an equation that only has y's in it, so I just need to solve it for y. Once you have a solution for y, we need to figure out what x is, so we'll take that number for y and plug it in, and figure out that x equals 2. Since this final answer does represent a point on the graph, we're always going to answer these systems as an ordered pair. A second way that you can solve systems is by elimination. To solve by elimination, you need either the x's to both have the same coefficient or the y's to both have the same coefficient. In this case, I could either multiply the second equation by 4, and then both of the x terms would have coefficients of 4, or if I wanted to make the y's have the same coefficient, I'd multiply the bottom one by 3 and the top equation by 2. Then the y's would be both have coefficients of 6. It doesn't matter which one you choose to do. Either one will work. A lot of times people like to get it so that one is a positive number and one is a negative number so that you can add straight down. It does work for both of the terms to have positive coefficients and then you're going to subtract. Any of those methods work. The way I'm going to choose to solve this one is by multiplying everything by 4. The top equation is going to stay the same, but when I multiply the bottom equation by 4, I get 4x plus 8y equals 56. If I want to eliminate the x's, I need to subtract straight down. So I need to subtract 4x minus 4x. It's eliminated. Negative 3y minus 8 is negative 11y, and 12 minus 56 is negative 44. Now I can solve for y and get y equals 4. I still need to go back and figure out what x is. I can plug this number for y into the original first equation, I can plug it into the original second equation, or I could plug it into the new second equation. No matter where I plug it in, then I'm going to go about trying to figure out what x is. As I look at those three, I think this is going to be the best choice. It's going to be the easiest to solve for x because x doesn't have a coefficient there. So I'm going to plug it in and get x plus 2 times 4 equals 14 and solve for x. I'll get that x is 6. So the answer to this system as an ordered pair is 6, 4. When you're solving systems algebraically, it doesn't matter if you use substitution or elimination. You're going to use what's most comfortable for you and what you like better. Both methods you can use on any problem, and both methods, if used properly, will get you the right answer.